alternatives, what they are, and why you shouldn't use them. The only one that I will recommend is Android. Android's cool. There are definitely a lot of fun things that you can do on the Android platform. Especially, my biggest thing with Android is it works using Java. The biggest difference between Apple and Google, people say Google's open source, Apple is super closed. Biggest problem though, people think Android you can just jump in, you can start threading things, you can start jumping into the root and do whatever you want. You can't. It's a closed framework, not as closed as Apple's stuff, but it is close. It's pretty limited. BlackBerry is awful. Performance is terrible. The hardware is terrible. Speaking of hardware with Android, that's another huge, huge issue. Hardware and software. There are hundreds of different types of Android phones. You're running ice cream sandwich, you're running gingerbread, you're running 2.2, and some of the older crap is running even worse stuff. So compatibility and testing is a nightmare. Absolute nightmare. And then you've got web apps. HTML5, that's what I started with. I actually started making web apps about 2 years ago and got interested in mobile stuff. There's a couple great frameworks, jQuery Mobile, SensuTouch. They are really great. I don't want to say really great at being bad, but that's kind of what they are. They're trying to be a native app on the web. The only plus side is you make one thing, works on BlackBerry, iPhone, Android. That's awesome. The problem is performance is terrible, your APIs are terrible, and you can't use any of the native controls. Camera, vibrating, your networking controls are really limited. Video is usually pretty terrible. And there's no 3D. Until we get WebGL, there's no 3D. So, why iOS? Huge, huge market shares. 70% of all phones, smartphones sold by Verizon and AT&T last year were iPhones. That's huge, humongous number. 90% of all mobile purchases, iPhones or iPads. 90% of tablets are iPads. Again, huge. And the reason, going back to the last slide, if you want to build something, say you want to build an Android tablet app. Well, now we've got a bunch of different versions of Android and we have a bunch of different tablets. iOS, you've got 90% of the market, and right now 2 different types of iPads. Similar hardware, and as far as operating system goes, almost identical. And before we jump into things, there's things that you should know about developing for iOS. I should take out the Apple computer, because I believe with Lion, OS X Lion, you are able to run virtual machines. People make Hackintoshes. I'm not going to condone it, or I'm not going to support it officially, but you can do that. So you need an Apple operating system. I would really recommend at least Lion 10.7, because that supports iOS 5+. $100 a year if you want to actually publish your stuff. If you want to just make things, put them on your own device, just your own device, and play with it, hack it, do whatever you want, that's fine, that's free. If you want to distribute anything, if you want to beta test, if you want to put something on the App Store.
I'm pretty sure you can't put, not to interrupt you, I know.
Yeah, no,
you can't use it on your own device if you don't have a,
you have to use a simulator unless you have a developer account or a student developer account.
Or jailbroken.
Or jailbroken. That's true. And what that $100 a year basically gives you, you have a developer account, you can provision, you can distribute, you can test, put stuff on the App Store, you can get betas of new operating systems, blah, blah, blah. The big thing for me, at least, is putting it on devices, not just one device, many devices, and then putting something up on the store. And you probably want to have device to test on. I won't really touch on this too much, but the simulator in Xcode is nice, but it's only a simulator. It is not an emulator. However much memory you have in your computer, in my case I have 8 gigabytes of RAM here, my simulator has 8 gigabytes of RAM, which is not right when you put it on a real device, when I should be using 256 or 512. So, some of the basics. The base language really is C. You can use C++, but the base, when you jump into things, the base language is C. Which leads to Objective-C. Objective-C is a subset of C. It's just C with more stuff, with objects, with lots and lots of objects. Cocoa Touch, which is basically a UI framework. It's got a bunch of these pretty nice style things that you can customize to an extent. Labels, buttons, sliders, all that sort of stuff. Really nice and simple for making. You mentioned you're using it in your senior design. I would use this. It's easy. It's really easy to make controllers, to make different views, to have buttons react to stuff. This is horrible for games. Don't ever use any UI kit stuff for games. Oops. When Apple developed it, they tossed in coordination, multitasking, and gesture recognition. iOS is a subset of OS X, which is a subset of FreeBSD, OpenBSD, or just BSD.
Well, it's Darwin.
Yeah. So Cocoa Touch is Apple putting on another layer to support gestures, animations, multitasking. There is a level of multitasking, as controversial as some of it is, there is some multitasking. Objects in UIKit. We've got two main types of things. We've got UIKit objects. Views, it's a UI view, UI button, UI text field. There's tons. Something you should get used to is Apple is incredibly verbose with naming things. There are several objects that are probably 30 characters long, impossible to memorize. Autocomplete is amazing. Your NS objects, NS integer, NS string, NS array, it's derived from Steve Jobs' original business, Next, and then they developed an operating system called NextStep. So they kind of prefixed all their objects with this NS. The NS objects are really strange. You won't be used to them when you first jump into them. Arrays, if you're used to PHP or Java, appending an array is not incredibly difficult. You just have an array and you're tossing more stuff onto the stack. With Objective-C, if you are declaring an array, that's your array. It's there, it's stuck in memory, it's not changing. If you want that to change, you have to allocate more memory for it. So then you have what's called an NS mutable array. And all the different data types, if they're supposed to be changing at all, they're mutable. NS mutable string, NS mutable dictionary, huge list of mutable stuff. But if you want to change something, the word that you want to look for is mutable, always mutable. I'm not going to touch much on 3D because I haven't done a whole lot of it on the iPhone. It's kind of difficult, but there are some people that are amazing at it. OpenGL ES, which is kind of the mobile version of OpenGL. Low-level UC, C++, it's fast. It's incredibly fast. If you've ever seen, what's one of the games? Infinity Blade is a good example. Incredibly beautiful game. Really great graphics. Running on this tiny little device with 512 megabytes of RAM and a teensy little processor. So some of our best practices. Functions. Functions are different. We don't really call them functions in Objective-C. We always want to call them messages. I call them methods because it's kind of right in between. The reason we call them messages is because you have an object and you want it to perform a task. So you send a message to that object. Just like in Java, you've got object.function name. In Objective-C, you've got bracket, object, space, message. So you just look at your brackets are encapsulation of your object is getting sent a message. That's pretty much how you're going to do it all the time. It's syntactically different, but it works just the same as a normal function. This is just kind of a brief demonstration of declaring a function or a message. If your return types, voids, bools, they can be NS objects, strings, arrays, anything. Your name, pretty simple. And the only other weird thing is this colon. Your parameters are divided up by colon, type, name in your function. Cool. Classes are super important. Objective-C is called Objective-C because it deals with objects. Objects everywhere. You always want to be building your own objects to be dealing with data. Your views are always objects. Your internet connection connections, your images, they're all stored in objects. And it's usually good to, if you guys have done, if you've looked into MVC, Model View Controller architecture very much, it's really nice to break up your program, your app, into models, views, and controllers. Apple's naming schema is kind of weird. Your views are called view controllers, but they're basically just views. Like I said, you want to make all of your own classes, but the important thing is your classes they don't need to, but they really should be subclasses of something. I mentioned the UI kit stuff earlier. If you want a button, but you don't want it to look like Apple's default button, you want it to be green, and you want it to have a border that's flowers. Well, you subclass a UI button, and on its draw function, you override it and do whatever else you want to do to it. Good. Yeah. Here's a little example of this class hierarchy that is built into UIKit. Everything in UIKit or the next step objects are derived from an NS object. You kind of move down the chain, you can see we've got menu items, let's see, responders, things that respond to gestures or touches, views, your application is a responder, your view controllers, and so on and so forth. It just goes down the line. And you can subclass any of this. If you want to have a super basic subclass, I would recommend just subclassing NS object. You can make a class that is not subclassed of anything. That's totally fine. There's nothing against that. But if you subclass NS object, you also inherit basic low-level functions that are built into UIKit. All right, so I'm just going to show you a quick example of an anatomy of a class. This is a basic view of the class. This is taken from one of Apple's example programs. The delegate stuff we're going to get into, so kind of ignore the very first line. The interface is our declaration of the class. Icon downloader is the class name, NS object. That's what so icon downloader is a subclass of NS object. And again, everything inside these little brackets up here are private variables. Declare them locally, use them in this object, can't be changed, initialized, or released from another object. The icon downloader is in control of all those private variables. All of these middle objects, everything that starts with that property, those are our public variables. Apple doesn't officially call them public variables, but that's the simplest way for me to think about it. All of the non-atomic retained stuff, we'll worry about later, not a big deal right now. But instance methods, kind of like in C++ where you need to declare your method and then later on you are defining your method. Same thing here. You've got a header file and an implementation file. So we're just defining our instance methods here. And then finally our delegate declaration at the top. I'm going to get into delegates later on. I'm not even going to mention it now. But this is how you define your delegate. And down here, this icon downloader delegate are the function names for our delegate. Just something to remember when we get to it later. Okay. So our at property. Whenever an object's declared with that property, you have to synthesize it. So, how many of you guys have ever used getters or setters in a program before?
They're called accessors.
Accessors, yeah. Probably some of you. Some languages take care of it for you, some don't. In Objective-C, you used to have to define your accessors. Now, they make you do this weird middle step, this at synthesize. So basically, you're declaring your variable with your at property, and then in your implementation file, you are synthesizing it, which basically tells the code, or the compiler, make a getter and setter for this variable. Kind of silly, but it's necessary. You also define the retention of an object and its property. kind of cover that later. Retention is a memory issue. If you want it to be retained, if you want it to be assigned only, read, write, read only, those sort of things. Implementation files, like I mentioned, you need to synthesize it. You define your methods, you say what they're going to do, and then you also have to deal with deallocating, which is the release of memory. Okay? So our delegates. It's kind of a weird, fuzzy, gray area. So this is kind of an example that I wrote, and I hope it's clear enough. If you guys have any questions, please raise your hand. So we make an object, image loader. It's going to load an image asynchronously. It's going to send a message to its delegate when it's finished loading its image. And it makes this, it declares a method, image did load. It does not define the message, image did load. It only declares it. Another object, myTableView, subclass of UI table view controller. So this myTableView is going to be displaying and controlling the data. MyTableView is going to initialize an image loader object. It's going to say, you, image loader object, fetch this URL, or fetch this image, load it. When you're done, it's going to tell MyTableView, I'm done loading. So MyTableView is the delegate of image loader. The other thing that MyTableView will do will be defining the image did load function. So if I can kind of piece this together, your image loader says that I have this message that I'm going to send when I'm done with something. Your MyTableView says when I receive this message, this is what I'm going to do. So an example would be lazy loading. You want to build a UI table view. You want it to show up on your phone, maybe with the name of all of the images. But if you loaded all of those images in your table view controller, your phone's going to sit there and hang until the default is 8 images are loaded, which maybe those images are not scaled down. Maybe they're 3 megs a piece. It's going to take a while, especially over a 3G connection. So you want your user to be able to swipe through and use the app even if those images aren't loaded. So you use this class, this image loader, to load things. And when it's loaded, tell the MyTableView, okay, I'm done with this, now display the image. So this is an example of syntactically how you would assign a delegate. Objects have a delegate property in MyTableView. In the MyTableView implementation file, you're saying, I want to be this object's delegate. That's the self. If you're used to other languages saying this, Objective-C always uses self. And then we're also defining the function image did load. So again, image loader says I can send this message. MyTableView says I can receive this message, and when I do, this is what I'm going to do. So in the example I gave, in this image did load function, we would have stuff like take the image, pop it into a cell, release the image. We're done with it. So here's kind of this loose, fuzzy definition stuff. MyTableView instantiates in the image loader object. Image loader owns the method image did load. Image loader sends the message image did load to MyTableView. MyTableView defines what image did load does. So hopefully that makes some sense. When you start off with these, with making iOS stuff, delegates aren't going to be huge. They will be important with some default UI elements, buttons, text fields, those sort of things. They need to have delegates to say what to do when a certain message is sent. This is a kind of graphical representation of a delegate. We have a view with a bunch of different stuff in it, in French I think. Table, table, button, inside of a view. So this is our view controller that contains all of this junk. Well, we have this view controller delegate that says, I am in control of all of those things, delegates. So you can have an object that delegates what button events do, what connection events do, what keyboard events do, all sorts of stuff. Memory management is a huge issue. I'm sure some of you guys have heard probably the most annoying and frustrating part with iOS is allocating and deallocating your memory. Whenever you create an object, it has to be allocated, initiated, and then when you're done with it, released. Leads to memory leaks if you don't. 512 megabytes is the max memory that we've got on these devices. Hopefully it'll be more someday. Probably will be more. But right now that's what we have to use. You should never be using that much. The Springboard app, which is what controls all the little icons and stuff, basically what controls your user input, takes up usually, I don't know, 60 megabytes of memory just to run. So I would really recommend never using more than half of your memory. And like I said before, there is some multitasking. Some apps will be running in the background, waiting for events, waiting for notifications, waiting for messages. Everything in Objective-C is pointer-based. That means when you initialize an object, you are initializing it in memory, saying this block of memory is, this is an NS string, is an array, etc. Kind of a basic example of how you initialize an object. Object name, that's simple. Little star means it's a pointer. You're allocating the memory, and then you're initializing it. And this is another example too of sending messages to objects. Our NSArray class method, we are sending, or our NSArray class, we are sending the class method allocate. And then in what is returned from that allocate method, we are sending an initialization method. And basically all this is going to do is give us an empty array. And like I said before, with the mutable and changing and all that sort of stuff, that thing is dead. That array is not going to do anything. It is not initialized with any data. You can't append anything to it. Different types of states. This is kind of frustrating sometimes too. Say you wanted to create an object, make it an animation object that you want to apply to 4 different images. Well, what you would usually think is I'm going to make one object for that animation and then give it to all 4 of my images. The problem with that is that one animation object is already defined in memory, and you're going to give it to those 4 images, and those 4 images are then going to be fighting for that one block. So instead we would have to use something like copy. We would have to copy that and basically make more and more chunks of memory saying, you get this piece, etc., etc., etc. We usually only worry about retaining things, which means we don't want the operating system to be in control of our memory. We want to say, this thing is here, it's allocated, it's going to stay there until I say to get rid of it. The only problem is that if you forget to get rid of it, it's going to stay there until your app's live, which can lead to memory leaks. It can lead to overused memory. If you've got a little array with like 2 strings, that's not a big deal. You could probably get by with that memory leak. If you've got 25 megabyte images and you don't release any of them, you're going to have a problem. Just like with the delegate example, if you're lazy loading all of these images, you've got 8, 3+ megabyte images loaded, you don't release any of those, and your person starts scrolling through a big list of stuff and you're loading more and more images, then eventually you're going to pull a ton of memory and your thing's going to crash. Kind of saying what I just said, has to be released. You're in charge of releasing it if you retain an object. The only, one more time. The only exception to this rule is in iOS 5, and continuing on, Apple introduced this thing called automatic reference counting, and it's basically a system that keeps track of how many objects you've instantiated, and it checks if that object is not being used, and if that object's instantiator, like my view controller makes an image loader object, if your view controller goes out of memory, well, you really don't have use for holding on to all of the things that it retained. So the automatic reference counting gets rid of anything else that you don't need to. Biggest problem is that you can only use your app on iOS 5 Plus, which isn't a huge deal. I mean, there are plenty of apps, or plenty of the devices are getting updated. But if you're, a AAA app maker and you want to make it for as many people as possible, you have to cover all those bases, which includes really down all the way to iOS 3.0, which they hadn't introduced the synthesizing for accessors, getters, and setters yet. Huge pain in the butt. Huge pain. There are a lot of good frameworks out there for making games, for accessing data, making REST calls, other sorts of things. The Cocos 2D, Unity, and Corona are game development kits. This AFN, or AF networking, that's a REST kit, which basically lets you send and retrieve data really easily. Takes a lot. There's a lot of work when it comes to getting data from the internet, web pages, images. If you're communicating with some server to Twitter, Facebook, those sorts of APIs. If you don't have a framework, it's kind of frustrating. It's not really hard, but this takes a lot of the load off of you, and it deals with things like timeouts, packet loss, all that sort of stuff. It's not really a problem unless you're creating a library or a framework. Apple, if you submit something to the App Store, will interrupt and deny your App Store submission if you are using compiled libraries. It's frustrating, but not really a huge deal, because you just import the source of the latest project that I've been using was using Cocos 2D. I import this humongous amount of files. I use it as normal. I build it. I compile it. Everything is usually fine. But it's something to just be wary of, especially if you find a framework that says here's the binaries. You can go ahead and just import these into your file and use it. Apple's going to say no. Contact info for me if you guys ever have any questions about creating apps. You're more than welcome to email, call, text. Always open. I'm going to go ahead and pull this up. I'm going to do a couple. Are there any questions, first of all? I'm going to kind of sped through some of that. If there's anything anybody doesn't get,
You go back one. Sorry. Thank you.
There's a bunch of other stuff I haven't covered, like testing, like submitting your stuff to the App Store. It's kind of a whole other ballgame that I don't really, especially as I'm assuming most of you are starting off doing some of this stuff. It's not really something that we should get into because it's just annoying. Apple's a pain. They close a lot of their stuff. Even getting your stuff on other devices to have beta testers is a tremendous waste of energy. But that's what they do. Alright. So I'm going to run through two quick examples. So first off, this is Xcode. If you guys aren't very familiar with it, it's a big IDE. It's not terrible, but it is slow. If you guys don't like Eclipse, you will hate Xcode. So I started a new project here. This is just a single view project. We have our app delegate. This is basically in control of our application. Header file and implementation file. I'm not really going to worry about this because, actually, you know what? I'm just going to start this from the beginning. We're making a single view application. What this gives us are these files called nib files, which I would recommend you stay away from because they make it easy to make mistakes. And it's also very resource intensive on the device to use these things. These nib files are kind of see what you get editor. I can drag drop objects on here. It's fine, it works for very simple stuff. But I would always recommend adding objects by hand. But again, I'm not the expert. You guys are more than welcome to do whatever you want. So on this side here, we've got an object list, just a whole bunch of different stuff. This is totally blank. Actually, I'll just run it and show you. Builds. Take this time. There. Big gray screen. So we want to add a view to this. Oh, wait. View. We have view controller. View. So we're going to toss a view onto this. And now we want to add an object. Text view. Run it. That shows up. We can fix that. Touch here, keyboard comes up. We can enter text. Biggest problem is we can't get rid of the keyboard. This is where our delegates are going to come into play. So our file is owned by, we've got a view controller nib here, an implementation file, and our header file. This is why I'm going to recommend not using the interface builder. You have to use something called outlets. And it makes this kind of simple. It looks easy and fun, and sometimes it is fun because instead of writing stuff, you're dragging and dropping. But then you'll get into a really nasty habit of always, doing this and not checking your code, creating objects that don't need to be there. You can pollute your application with objects that don't even get released. So we've created this object here, and we're going to add a delegate. The screen is so tiny. Our delegates are always in these open carets. So we're at a text field delegate because this is a text field object. Make sure everything works. Cool. But still, this comes up, not going away. So in our code, we got to do two things. The first one is when our view loads, we want that text field to recognize this controller as our delegate. So we called it my text field. Our delegates equals self, kind of like in that example I showed. And what this does is when you add a delegate like this, it's almost the same as importing files. It basically gives you access to a bunch of different functions, a bunch of different messages. They're going to be sent to this controller when an object sends them. So the message that we are looking for, that we want to intercept, is a bool text field should return. Basically, whenever we are hitting the return button. You can see in our parameter here, it's passing a UI text field. It's the same as the sender. And this text field is just going to be the text field that we declared up here. This is my text field, because that is the one that's saying that view controller is my delegate. So all we're going to do is text field, and then to get rid of keyboard is this message resign first responder. Super simple. I didn't put a return in there, so you might get a crash, but very simple. We can do all sorts of different stuff with this interface builder, but again, you get used to visualizing what you're doing. The interface builder, you can't customize your objects. You can do things like color, you can't do shape, you can't do images, data tables, table cells are difficult. Scrolling is very difficult. Gesture control is also super difficult. So it's not something that I would recommend getting used to. I would say you do everything in your code. You can add objects to your views, remove objects from your views, change them, etc. Is there anything that you guys would like to see? I mean, there's a whole world of stuff
What you did.
done with this. What's that?
Show some of the projects you've done.
Projects I've done. Here's one that this is an Apple project actually. This one's good. This is that lazy loader stuff that I was talking about. I'll show what the app does here. Now you see we've got all of our images loaded. We've got our text loaded. But what's really cool about these table views is when you actually scroll to something, it's not loading the entire list. It only is going to load what you've got on the screen. So as I scroll, it hasn't loaded our images. And it loads them in as they're finished downloading. And where is that? We got our icon downloader object here. This is the exact same as the example I was showing. This object is doing all of our downloading. And then we have this view controller. It's Apple's documentation. That goes through somewhere here. Creates these icon downloader objects and waits for waits for these objects to send a message back and say that I'm done. I finished loading. Go ahead and put my image on the screen. This is a work in progress. This I used a combination of nibs and doing stuff in the code. This is a really awesome UI kit object. This bar up here, it's called a UI navigation controller. And all that you really do is this controller has a stack of views, and you can push and pop things onto the stack, and it automatically puts a back button, puts the title of the view up here, and you can just pop through all of these different views and then navigate back through them kind of on whim. And the actual creation of it is really, really simple. You just instantiate a UI navigation controller, and then you make view controllers and just consistently, let's see if I can find it, push onto the controller. Where are you? Well, it's in there somewhere. So like, the way it works right now is this button here. I have an event that says when this gets pressed, push another view onto the controller. That does that. And then this button is generated for me, the toolbar is generated for me, and I can jump through the views as much as I want. There's a map kit, which is powered by Google Maps. Comes with the SDK. Very easy to use. There's the core animation stuff. You can get fun things like that. And through all sorts of different problems that you have. The community is also huge. You know, there's stuff like Stack Overflow. There are a million different questions on there. But on the presentation, the one last thing that I would like to show you guys is resources. Start on that slide. I taught myself using this book. I did iOS 4. The new one is iOS 5. I think it's an early release right now. I don't think it's an official. It's like $40, but it's incredibly good. There's a lot of samples. It starts off assuming you have no knowledge on how to program, so it goes through like, you know, here is how to do a for loop, and here is how to do integer addition, all that sort of stuff, and moves you on through building sample applications. You're using maps, you're doing URL requests, and eventually in the end, you built an app. I mean, it's a demo app. It's super simple, but you get the idea. And it's also extremely thorough on telling you all of the different ways to do things. How to use the interface builder, like with those nibs, to just drag and drop objects. It tells you how to do everything from code. It tells you how to customize stuff, how to subclass properly, etc. So if you're interested, definitely check out that book. But on top of that, like I mentioned, Apple's documentation is really good. They have extensive documentation on every object, on every method. And they have a lot of sample code out there too that's usually pretty heavily commented. They're usually really great reads. So that's about all I've got. If you guys have any questions, toss them at me.
Maybe you can go over just a little bit about actually using iOS hardware, because for our project we have a radio transceiver that plugs into the iPod, and it doesn't work with the simulator. So
iOS hardware.
I was wondering if you could talk a little bit about actually building stuff to run on hardware instead of the simulator.
So how to deploy
Yeah.
onto a device? Okay. So first off, you need a developer account, like we talked about. And yeah, there's a bunch of good resources, but basically, you go to, let's find it, Apple's website. You log in with your developer account, and there's this thing over here on the side called the provisioning portal. You can go through here, click on devices, and add a device. All of your devices have this big string. It's a UDID, it's a 40-character unique string that once you add it to your profile, so you can see I've got a bunch of testers here. Once you add it to your profile, all that you need to do to test yourself, I'm not going to really go into distributing. I'm going to plug this in. Right here. We've got our simulator list up here, iPad and iPhone. And as soon as this gets recognized, there we go. As soon as that's loaded, there's my phone. I'm going to do there, and I would hit run. Build, compile, puts it on here. And then all that you have to do is you stop it here, unplug, and it's on here. You can use it whenever you want. They do expire. I think it's about a 90-day provisioning profile, but that's a lot of time. And if you want a new one, all that you have to do is go back to the provisioning profile and make a new one. I'll show you guys a quick little thing as far as distribution goes. This is cool. I just found this the other day. Now we're starting to use it for our senior design. This testflightapp.com. You can make a profile and upload builds, which there's a bunch of stuff on making builds, but I can assign testers that I've provisioned in the Apple provisioning portal. Assign them to the build, hit complete, shoots them an email, they can install it through the email. I get session reporting, shows how long people play, how many sessions. I get crash reporting on certain devices. I can get the stack trace there. You can also in the app ask for feedback. You know, have a little pop-up that says, hey, what did you think of that level? Or do you like this app? Or something, you know, what's going on? And when they hit submit, it shows up on your dashboard. Pretty cool tool. If you're ever seriously looking into developing and distributing apps, I would strongly recommend this. It's free. It's totally free. It's super, super nice. You guys got anything else for me? I appreciate y'all coming out. And again, if you have any comments, questions, you need help, I'm in the ACM office a lot, and even if you guys want somebody to sit you through or walk you through building something or helping you through something, I'm more than willing to help you out. So thanks, guys.
Thank you. How many iPhone developers on campus do you guys talk or meet?
I stay kind of close knit in the CS program, and I don't know anybody else that does iOS stuff. It's an awesome framework, and it's fun. The Apple stuff's really cool, and there's nothing wrong with Android, but there's something about putting out an iPhone app that's just awesome. Thanks, guys.